Now we talk about another entropy coding system, which is Huffman coding. So in case of Huffman coding, again we have to consider an algorithm, and the steps of algorithm are written here. The first step will be source symbols which are given to you are assigned in the order of decreasing probability. Then the two symbols of lowest probability are assigned 0 and 1. The second step will be combine last two symbols and then move the combined symbol, that means added symbol, in the required position. In the third step, we given repeat the steps until we are left with the final list of source symbol of only 2, for which 0 and 1 are assigned. That means in the last step, this step will be repeated until we get only 2 values. And the last step will be code for each symbol is found by moving backward. So let's consider an example, then you can easily understand the process. So a problem is given to you, 5 alphabets with their probability 0.4, 0.1, 0.2, 0.1 and 0.2 is given for the symbol SI. That means it is S1, S2, S3, S4 and S5. Find the Huffman code. Also find the efficiency for the code. So to find this, again we have to consider the steps that we already discussed in our previous section. So the first step will be arrange all the probability with their symbol in the decreasing order. So symbol S1, S2, S3, S4, S5 with the probability 0.4, 0.1, 0.2, 0.1, 0.2. But this is our not required criteria. We have to find them or arrange them in the highest to lowest. So we write them first 0.4, 0.2, again 0.2 because 0.2 2 times is there, then 0.1 and again 0.1. After that, second step will be combine last two symbols, that means these two. When added, it gives 0.2. 0.1 plus 0.1, it is 0.2. And then place this new symbol in the required position, where that means after 0.2. This 0.2 after that here. So the new list will be looks like it is 0.4, 0.2, again 0.2 and for this it is 0.2. Again the step will be, new list will be this. So we have to add last two symbols which is given as 0.4. Then this 0.4 is written here. So this 0.4, again this new 0.4 and 0.2. Here you should remember this, the first 0.4 which is already given in the question, right here, and then the added bit is right here. Why? Because 0.4 is always greater than 0.2. That's why we written this 0.4 upper to the 0.2. And then 0.2, this 0.2 is written here. After that, again we have to add these two symbol which gives 0.6. Now 0.6 is greater than 0.4. So this 0.6 is written here and then 0.4 is written here. So this is our, after that no further addition is possible because the final subset or the final list contain only two symbols with their probability. Now we have to there is another task, that is always write the upper symbol or the upper probability as 0 and the lower probability is 0.4, I mean 0.1. That means 0.6 is denoted 0 and 0.4 is denoted 1. Here also this is 0.4 and this is 0.2. Now you can see that as these 0.6 is derived from these two values, therefore we have to write here it is 0 and it is 1, but as it is derived from 0.6, so left side of this 0 we have to put another 0. This 0 and 1 is for, this is upper value, that means this is the highest value, that's why I denote is 0, and it is 0.2 lower value, that means we put point is 1. But this 0 is written because of this symbol, because this 0.6 is derived from these two values, and for 0.6 we denote the message as 0. So this 0 is written here. So it is 0, 0 and 0, 1. And 0.4 we write here 1. Why? Because this 0.4 is this. That's why this 1 will be written here. After that, in the third step, we move to backward. So this set is, now this set is denoted as, that means 0.4 is derived from these two values. So therefore it is written as 0 and it is 1, but this is from 0, 0 and it is also 0, 0. Why? Because this 0.4 is derived from this. So that's why I denote 0, 0. It is also 0, 0. This 0, 0 is denoted for this symbol. So that's why this 0, 0 will place in the left side of this symbol. And 0.2 is coming here. So it is 0.01. 0.4 is again 1 because of this. Now again this 0.2 is derived from these two symbol, that is 0.1 plus 0.1. So that's why we denote as 0, 0, 1. It is also 0, 0, 1, and as we divide these two, upper symbol, it is lower symbol. So that's why we put 0 and it is 1 for these two symbols separately. Now the value of 0.2 is this value. So it is 0, 0, 0. Again it is 0, 1 and it is 1. So our final code word will be for 0.4 it is 1, 0.02 it is 0, 1, 0.2 it is 0, 0, 0, 0.1 0, 0, 1, 0 and also 0.1 0, 0, 1, 1. So it is our required code word. Now we have to find out eta. So eta value is again similar to previous one. So that means hx by L. You can find out yourself. I only represented the answer, which is 58%. Check it by yourself. So here it is another problem. A DMS has 6 symbols x1 to x6 with probability having 0.30, 0.25, 0.20, 0.12, 0.08 and 0.05. Find the code words and their efficiencies. So here it is your solution. Here list the symbol with their probability with decreasing order. So it is our symbol and it is the probability with their decreasing order. Now our next step will be add last two symbol. This is last two symbol. The value will be 0.13. This 0.13 will be added apart to this. So it is right here. So now in the second list, the values will be 0.30, 0.25, 0.20, then 0.13, then 0.12. After that again these two are added, and it is when added the value will be 0.25. So here it is written. Now the list will be 0.30, 0.25, 0.25, then 0.20. Again these two are added. So value will be 45.45. So this 0.45 is written here. 0.45, then 0.25, sorry, 0.30, 0.30 and 0.25. These two is added, but this is left. So I write this. Again these two are added and written here. So the value will be 0.65. That means 0.55 and 0.45. This is our final value. Now we have to denote it in their code word. So we put them uppermost value will be 0 and lower is 1. Now as this 0.55 is derived from these two values, so here this 0 is written here and here, and for 0.30 as it is upper value, so I write here 0 and it is 1. So this 0, that means this 0 value is denoted because of this. Understand everyone? This 0 value is denoted here because of this. Because 0.55 is created because of adding these two symbols. And 0.45, the coding is already given 1. Again, this 0.25 and when we add this 0.25 and 0.20, we get this symbol. So therefore we write here 1 and 1. And after that, for upper value, we denote 0 and lower value 1. This 0.5 is for this. So I write here it is 0.01 and 0.30 is 00. Again, these two value we denote as 0 and 1, and as this 0.25 is derived from these two value, so we put them 0, 1, again 0, 1. 0.20 value is 1, 1. It is here. And 0.25, this 0.25 is for this, so it is 0.10. And 0.30 equals to also 0, 0. Again, these two symbol when added we get 0.13. So therefore, this because of this 0.3, the code word is 010. We just put 010 for both, and then for upper value we write 0 and for lower it is 1. Left the values are already given. So no need, just I have write it here. So we get our code word. So the code words are for x1 it is x1. For x1 value is 0.30, so therefore it is 0 0. For x2 it is 1 0. For x3 it is 1 1. For x4 it is 0 1 1. For x5 it is 0 1 0 0, and for x6 it is 0 1 0 1. Then we easily calculate eta value, that is hx by L. Find it yourself. The answer will be 99%. So a problem is given to you. A DMS has 5 symbols x1, x2, x3, x4 and x5 with their probability is given here. It is 0.19, 0.16, 0.4, 0.15 and 0.1. Remember the word if you cannot read it. It is 0.19, 0.16, 0.4, 0.15 and 0.1. Construct the code word using Huffman coding techniques. Also calculate the efficiency. It is your task for today's. Find out the answer and tell me.